So we've been through the terminology, okay, on avirulence and virulence, susceptibility and resistance, incompatibility and compatibility. And then I went through and gave an explanation of how Flor went about doing his studies that led to the formulation of the gene-for-gene hypothesis. And then at the end of before we had lunch, I made the point that we use the gene-for-gene hypothesis pretty much as the foundation for all the genetic work we do in resistance breeding. Okay, and there are two ways in which the gene-for-gene hypothesis is applied in genetic approaches to controlling rusts in cereals. The first of these is where we have a known host genotype, and we use that known host genotype to characterise the genotype of the pathogen. And this is what we do with race analysis or pathotype analysis. So we take differential lines, we know what resistance genes they carry, and we use those known genetic stocks of the host to characterise pathogenicity in the rust. All right? The second approach is where we have a known pathogen genotype, and we use that known pathogen genotype to characterise resistance in the host using the gene-for-gene hypothesis. And this is what we do to characterise what rust resistance genes occur in wheat, for instance. All right, and that helps us from a number of perspectives. One is so that we know what resistance genes are present in our wheat varieties. That's one example. Another one is in gene discovery. It's how we actually find new rust resistance genes. So what I'm going to do is just go through each of those two applications of the gene-for-gene hypothesis. So the first one, as I said, known host genotype, unknown pathogen genotype, race analysis or pathotype analysis. So here we have three differential lines. Don't worry, I'm not worrying about what genotype they are, but let's just say we know already that each of these three differential lines carries a different rust resistance gene. Somebody sends us a rust pathogen isolate from a field somewhere in the world, and we use that pathogen isolate to infect those three differential lines that we know the rust resistance status of. And in this particular case, this isolate gives a low infection type on differential 1, a low infection type on differential 2, and a low infection type on differential number 3. The conclusion is that this particular isolate, this pathotype, is avirulent for the resistance genes in each of those three differentials. Quite straightforward. Second pathogen isolate is sent to us from somewhere else, and we use that unknown pathogen genotype. We put it on those three known host genotypes, and we see that in the first one we end up with a high infection type, the second one a low infection type, and the third one a low infection type. So we can conclude that isolate 2 is virulent on differential 1 and avirulent on differentials 2 and 3. Third rust isolate is sent to us from another wheat paddock from somewhere, and it is low on differential 1, high on differential 2, low on differential 3. Okay, so we can then say, of course, that this particular isolate is avirulent for differentials 1 and 3, virulent for differential 2. Then a fourth one, we end up with compatibility or a high infection type on all three differentials. So in this particular case, we can say that isolate 4 is virulent on all three differentials. So we've used three differential lines that we know the resistance gene status of each to characterise the pathogenicity of 4 rust isolates. And we've been able to show that each one is a different pathotype. All right? They're all different races, different pathotypes. They differ in their pathogenicity, and the bottom line there is cut off. They differ in their pathogenicity on the three differential lines. They are therefore 4 different pathotypes. Very simple, I know, but this is the essence of what we do in pathotype analysis. And it's based on using the gene-for-gene hypothesis, right, to deduce a pathogen genotype from a host genotype, from a known host genotype. So that's the first application of the gene-for-gene hypothesis.